Hello, my name is Bruno Massa, Vice President of the SimCenter Testing Solutions. I have the pleasure today to give you an overview of the different challenges in relation to test-based engineering and how they relate to actual product innovation, but also to efficiency and productivity. We will be showing you a number of very practical examples in terms of how we have implemented that in our systems and software, but also talk about different realizations with customers in different industries. When we talk about challenges for testing, of course, it's in the context of the overall product engineering challenges, and it's a lot about innovation. It's about continuous innovations, developing ever new products, applying ever new materials, compositions, also new manufacturing techniques. And needless to say that in itself creates a lot of new challenges for the way that testing, physical validation is done on these products. First of all, test departments need to really support the product innovation, bringing a new product to market, and allowing basically that all the different quality criteria, performance criteria of these products really match with the overall brand positioning of a product. When a car manufacturing, for example, applies new lightweight structures, really the car needs to comply with the expectations in terms of structural integrity, but also with the reliability and the durability of the vehicle. When a new e-powertrain is applied in a sporty vehicle, then the sporty vehicle also has to comply with the brand sound, for example. So that in itself creates quite an important new challenge for test-based engineering. Secondly, it's not only about single performance attribute, it's not only about durability, structural integrity, or performance, or noise, or acoustics. It's about bringing the right balance between these different attributes, and still very late in the product development stage, when the prototype comes together and the product needs to be physically validated, really one can really balance and check whether the balance within the product is available between these sometimes conflicting attributes. And very often still, testing is the only real way to do that balancing and to do the final tuning towards or before the actual release of the product. Now finally, innovation is about creating a lot of novelties and uncertainties into a product. One can handle to a certain degree these uncertainties with simulation, but next to that, really testing plays a key role to validate how these novelties really react, how they basically perform in real life through testing. To basically validate then the product based on testing, but also to provide that input back into the simulation models and to improve the quality and the performance and the reliability of these simulation models. So that's basically in a nutshell what it means, what product innovation actually means for new challenges for testing. Next to that, all of that product innovation also has to happen into a reduced timing to market, and it also creates new challenges for efficiency and productivity and faster testing. But faster testing, of course, without room for errors, without room for, let's say, reduced reliability in testing. That basically means that all kinds of inefficiencies in every step of the testing process really needs to be eliminated. There's no room for that anymore. So test departments really need to review their practices, need to apply new practices, a new way of working. But they also need to do that in the context of globalization, which means that some part of the testing might be done on one side, but also one needs to cooperate with other engineering teams, with suppliers, with institutes, with research innovation institutes, and all of that needs to be fit together in kind of a distributed setup for doing test-based validation. Now this picture is quite challenging in terms of combining product innovation in a shorter time frame to be able to do more testing on less prototypes with more insights. And we basically from SimCenter Testing Solutions have worked very hard over the past years to be able to address these challenges in our solutions. And we do that actually by first of all providing a full integrated set of solutions, combining multi-physics data acquisition systems in different sizes and different flavors, also addressing a broad range of physical and analog sensors. Secondly, combining that with a software suite for not only data acquisition, but also in-depth data analysis and data analytics. And thirdly, applying also in those capabilities, software and hardware capabilities, multi-physics, multidisciplinary type of engineering content, engineering know-how, so that the system cannot just perform a single measurement, but can also provide the engineering teams with the critical insights in how their designs are performing and how basically designs can be improved and optimized. And with that, we basically cover a quite broad range of applications, starting, of course, as we are renowned from our background from the core applications in NVH, but also expanding into acoustics, expanding into durability, dynamic environmental testing, and actually supporting all of these applications in an integrated hardware and software solutions so that teams can acquire their data in a unified testing type of approach, really instrumenting a test object once, capturing all the data and being able to analyze these data within these different disciplines, but also to basically allow to balance and to cross-check how a certain performance in one discipline needs to be balanced against a performance element in another discipline. And that's quite a unique, let's say, proposition that we're bringing with our SimCenter testing solutions. So with SCADAs and with TestLab as hardware and software platforms, but also doing that in a very integrated way, and also, as we will illustrate with a couple of examples, with a clear link to the simulation worlds, 1D simulation, 3D simulation, and CFD simulation. Further in today's presentation, we will zoom in on a couple of key aspects that really determine how you can basically support product innovation while being more efficient. In that context, we will talk about how you can speed up data collection, which is not only critical in terms of gaining time, but also assuring the quality of your measurement and what you can actually gain as insight from your measurement. Secondly, we will really talk about how you can make the step from pure measurements to really insights in terms of how your product is performing, what the root cause is of a certain problem, and how you can also optimize and improve your product. And then thirdly, we will clearly talk about all the different ways we connect to simulation, why that is important and even essential, and how, with both practical methods, but also clear connections and integration between tools, we allow tests to enable simulation and simulation to enable test, and to really work together in a combined way. Today I will also be supported in my presentation by Mr. Gert Sablon, Business Development Director for the SimCenter Testing Solutions Group. And Gert will actually start with giving some practical technical examples in terms of how our solutions can actually speed up the data collection in this context of new product innovation and increased efficiency and productivity.
Thank you very much, Bruno, for your introduction. My name is Gert Sablon. I'm Director of Business Development in the Test Division, and I will take you to the next part of this presentation. In this next part, I will show you how we can help you speed up data collection with SimCenter TestLab and SCADA's hardware. Let me start with the data acquisition hardware. SimCenter SCADA's comes in many different shapes and sizes. The first member of the family is the SCADA's Lab. SCADA's Lab is a 19-inch frame especially fit for laboratory purpose. It supports up to 480 channels, but if this is not enough, no problem, you can always add more channels to the system. Up to 1,000 channels are supported. For mobile testing applications, SimCenter SCADA's Mobile and SCADA's Recorder are well fit. These platforms support up to 200 channels without any problem. The smallest kit in the family is SimCenter SCADA's XS, supporting a full day of working with its 6-hour battery lifetime and more than 12 channels of data acquisition. Moreover, they're all very rugged and shockproof. The SCADA's family has actually been developed for unified testing. So rather than investing in single solutions, single point solutions, the SimCenter SCADA's family supports it all in one go. This example shows a preparation by means of SimCenter 3D pretest, where a model analysis on an airplane is being prepared. In SimCenter 3D pretest, the correct positioning of the sensors can be done in such a way that not only the right amount of sensors can be defined, but also the location of the sensors can be such that all the different mode shapes can be for sure measured correctly. This is what you could see in the MAC matrix that was shown before. After this setup is done in SimCenter 3D, the data can automatically be transferred to TestLab and connected to the TestLab channel setup page, such that automatically all the measurement channels are configured in the right way. Once the data acquisition is running, also there we have some tools that support the users to make sure that errors are minimized. What you can see on this slide is actually our SimCenter Control app. The SimCenter Control app can be used for mobile testing to make sure during the measurement itself that all the measurement channels are correctly registered. For instance, here you can see a display where in yellow and red we also indicate alarm and warning levels. Once certain levels, both in the negative and in the positive direction, are reached, the app clearly shows the status of the signals. If not, the measurement can be done immediately, saving in that way an enormous amount of time, because if you only find out that the measurement needs to be redone the day after, that will of course cost a lot of extra time. A last example of how we can help speeding up data collection is in the case of, for instance, transfer path analysis. In the case of transfer path analysis, typically geometry information is not always used, yet huge amounts of frequency response functions are measured. This example shows a data set where we have measured more than 4,000 frequency response functions. With this matrix heat map display, in a glance of an eye, you can immediately see whether there are problems with the data set or not. The dark blue line in the graph shows a clear phase error. You can see the misalignment of 180 degrees, and this type of error can be easily corrected for. In this way, the data set can be made consistent, and again, in that way, it can be used immediately for correlation and updating with the required simulation models.
We've shown you basically how you can actually accelerate your test preparation. That's the whole start of the setup, not only to make it faster, but also to ensure that you capture the right quality in your data. Secondly, also to introduce the concept of standardized tests in the context of advanced engineering, because that really allows to introduce repetition, but also productivity in the way that you execute your testing. And then thirdly, of course, it's very critical that you have the appropriate methods, but also tools available to validate your required data and to immediately, basically after the test, starting your analysis and starting creating insights on your data. And that is something that we will elaborate more on in the next section of this presentation.
Now that we have acquired all the data, the next step is converting these data that we have measured into real engineering insights. Let's take a look at that subject for the next few slides. First, there's a few problems and difficulties to overcome. In the introduction of this presentation, we actually refer to the fact that less and less prototypes become available. Therefore, we see a trend where on the little amount of prototypes that are available, as much data as possible are measured, even spanning different disciplines. As a consequence, of course, massive amounts of data are the result of measurement campaigns, and preparing those data for further analysis is a difficult task to solve. Secondly, this type of work, checking the quality of measurement data and chopping them up for the right analysis to do, is not so much a difficult task, but it is a very repetitive task. Here we will show you that TestLab software can help you automating these kind of simple and repetitive tasks, and in that sense make them easier to solve and also yield a higher quality of resulting data. Last but not least, it is also important to know what kind of settings you use for the analysis. Different settings can lead to obviously different results, but this can lead to misunderstandings because the data were the same, but by processing them differently, you could come to different conclusions. Also here we will show how TestLab can help solving this type of problems. As first example, let's take a look at having data as a result of a long measurement. Here you can see actually GPS data measured during tests on a test track, and we can clearly identify an upper loop and a lower loop. Many runs over these two loops in all kinds of different directions have been taken. TestLab Neo software actually enables you to automatically cut all the measurement data in the different loops. Data measured in the upper loop are separated from data in the lower loop. Even more, data measured in clockwise direction are automatically separated from data taken in counterclockwise direction. As you can see here, this kind of definition for the analysis and chopping up of the data can be easily done in tools like Google Earth, where pins can be set to identify the exact GPS locations that define the difference between the different types of tracks measured. As a next step, the processing is important. As I said in my introduction, it is very important to know with what kind of settings the data are analyzed, because using different settings might lead to confusing results. If data are analyzed in a different way over different departments or even between different suppliers, and it is not clear that these settings were different, this can lead to misinterpretations. A solution to that is to automate the tasks of data analysis, and the process designer in SimCenter TestLab supports this task very well. As you can see here, the definition of a processing and analysis task can be done in a graphical way. Every different block corresponds to a step in the process, and in order to make the process really well documented, as you can see, it is possible to add pictures, to add comments, to group certain different tasks into a standard task, and save those grouped tasks even in a library such that you can share it with colleagues within the department or over different departments. In that way, we can assure that the same analysis, the same processing is applied over and over again, and this helps in standardizing the process of data analysis. It is also very important to use the right tool for the right task. Here we show you our SimCenter sound camera. SimCenter sound camera is a digital array that allows to localize acoustic sources on any type of object. The arms of the sound camera have various sizes and can very easily be exchanged. In that way, from changing from small to bigger arms, like you can see here, with the sound camera you can actually span multiple applications and also the complete frequency range. Sound camera is a versatile tool. It can be used from very small handheld equipment up to very large heavy equipment like bulldozers, for instance. Unified testing has always been at the core of what we try to design in SCADAS and TestLab. In this case, you can see an example where we do a measurement on a chassis dyno, and the measurement object is an electrified car here. And together with classical NVH analysis, we also combine here different other disciplines. As you can see in the pictures, with the sound camera, we combine this with a live sound source localization to watch the acoustic sources. But we can also include in the same image, for instance, video footage that shows exactly what the driver of the vehicle does when, for instance, switching the driving mode of the vehicle. And then, of course, it immediately becomes possible to see what kind of influence this has on the actual NVH behavior of this electric vehicle. In the other graphs, you see that at the same time we can look, for instance, at sound quality metrics, looking at more subjective perception of what happens here. Transfer path analysis has always been the method of preference if people really want to get to the root cause of very complex problems. There is one little disadvantage to transfer path analysis in the classical way, that is, you always need a physical vehicle to conduct the measurements. Well, with component-based transfer path analysis, we will change this. With component-based transfer path analysis, it actually becomes possible to do a transfer path analysis not based on a full vehicle, but based on individual measurements on the single components. These individual measurements can be taken in situ, in the vehicle, or also on a test bench. We actually come to independent loads for every component. These independent loads are then stored in a central database, and in this central database we can characterize the components not only by means of measured data, but the models of the components could also come, for instance, from CAE calculations. With the models available in this database, we can then start to assemble virtual vehicles. Any type of combination of components can be taken to represent all the variants of a vehicle model for which not all the physical models are available. And in this way, the classical idea of transfer path analysis can now be exercised much earlier in the development process.
We've illustrated how you can basically convert your measurements into insights and basically make your product better, basically bring an innovative product to market. So we talked about the interactive and automated multi-domain analytics to be able to not only speed up your analysis, but also to be able to relate one phenomenon to another phenomenon, which is quite crucial in terms of understanding and improving your product's behavior. Secondly, we talked about identifying the root cause and really compare the data in a very prompt way. That's actually quite crucial to come up with design improvements and to basically also be better than your competition when it comes to the performance of your product in different aspects. And last, of course, it's also very important that there's very convenient ways in terms of sharing your insights and also reporting. And I think that's what TestLab is very well renowned for in terms of the famous reporting capabilities. They have a very smooth way to come from your actual data acquisition, your analysis, and translating that into insights and workable reports in Word, in PowerPoint, or even dumping your data in Excel when needed. So with that, we've talked about the analysis part, and now we're ready for the last part of the presentation.
In the last part of this presentation, I will show you how we are more and more connecting testing and simulation tools. Connecting testing and simulation tools actually supports the usage of a digital twin. There's different ways to connect testing and simulation tools, and let me start with the more classical way of doing that, which is using test data in support of simulation models. First of all, test tools are very regularly used to measure realistic loads. Realistic loads to be used for driving simulation models, because simulation models, of course, need good input data to yield correct results. In the next example, I will show the other very well-known example of test supporting simulation. And that's an example of ground vibration testing, where a physical test on an airplane is actually used to validate the simulation models that are being used for developing the aircraft. Here you can see how TestLab is first used to do modal analysis. The Polymax estimator shows a very clear stabilization diagram where you can pick the modes. And the first thing to do then to validate the modes that were calculated is to look on the geometry, animate the modes, and see if they make physical sense. In the next step, we will also compare the synthesized frequency response functions with the measured ones to make sure that our model is accurate, and also data quality checks like using a model assurance criterion, like you can see here, can be used to see if the modes that were found are really physical. Then as a next step, we're going to import these test results in our simulation environment, where we can compare the experimentally found modes with the modes as computed by the CAE model. And then, of course, by using the differences between both, we can try to improve the simulation model such that in the end it matches the set of measured data in the best possible way. But we are going further than that. We are actually finding and implementing new ways to connect test and simulation with each other. And in this next example, we will show you how simulation models can also be used to enrich test data. In this case, we look at a different type of simulation, being 1D simulation. What we have done here is we have actually implemented a deep integration between our SimCenter AimSim software and TestLab. As you can see here, in TestLab Neo, we are running the sketch viewer, showing immediately the 1D model as it was authored in the AimSim application. In that way, we can immediately access the data that were simulated in the model by simply clicking on the right component in the sketch viewer and selecting the corresponding channel. By looking at the simulation data in TestLab, we can of course also imagine that it becomes very simple to compare the simulation data with the test data measured on the same object. And from there, of course, we want to find out how good our simulation model is. So in this example, we are taking the data now from the test model. We will define some calculations on it and compare the test results with the simulation results. If you take a closer look here on this picture, you will see that there's actually quite a big deviation between both, indicating that the simulation model is not fully reflecting reality. That brings us to the last step, which is the real full integration of test and 1D simulation that we have in our latest version of TestLab Neo. So we are bringing them as close to each other as possible. Since we had this simulation model in the previous step that did not yet yield the right results, what we will do now is, instead of loading just the results from the simulation, we load the model as a functional mockup unit. This allows us to actually run the simulation model in real time, but from within TestLab. And even more, as you can see here, we can now start playing with the parameters. We can change the values of the parameters, and by modifying those parameter values, finding a way to get a better match between the simulation model and the test data. In this case, you will see that doing then exactly the same calculations to get some end results, now we get a much better fit between the blue line and the red line, showing the test data and the latest version of the simulation model.
So these are again a number of examples, both technical implementation examples in TestLab and SCADAs, and also customer cases on how basically you connect your testing capabilities, your testing operations to simulation. And more, I think it's become a day-to-day reality. It's not only about either simulating or testing, it's really finding a good combination of the two worlds. Basically to use simulation or to basically use testing to provide the required loads and to provide the required inputs to simulation, to make simulation more accurate and more to the point. Secondly, also going one step further and to really embed simulation more and more into physical testing, to take advantage of the speed and the agility of simulation during your physical testing. And then, last but not least, also basically fine-tune a simulation, update your simulation models directly from your test data, your testing insights, so that your simulation becomes more accurate and also becomes more usable in the real exploration of innovative designs, and to basically to neutralize, to detect the unknowns that come with simulation. We think that from this perspective, the combination of simulation and test and the more tighter integration and embedding of both worlds is really the only way forward. And of course, I mean, with SimCenter, the overall test and simulation portfolio, we are extremely well positioned to do so. So with that, I think I want to also bring to the attention that within TestLab, we do not only have these broad span of different capabilities in the TestLab software, multi-domain, multi-physics, but we also have a quite unique way of being very flexible in using these tools with our value-based license, our token principles. That really allows, based on having access to tokens, to not having to decide upfront which type of licenses, which type of capabilities you buy as a user for the software, but you buy actually a right to use quite broadly all the capabilities within the software, depending on your needs at a certain period of time, giving you the flexibility to use other capabilities without having to acquire those upfront or on the spot, but also being able to try out new capabilities without having to upfront basically buy the additional licenses. The token principle is really something that has gained a lot of, let's say, usage in our installed base, has become very popular with many customers, small, medium-sized customers, but also big customers, and giving you as a customer a lot of flexibility with a limited investment in the software, having access to a very broad span of capabilities, and many of the exciting things that we actually talked about today in the presentation. So with that, I want to wrap up the presentation of today. So as you recall, we actually gave, I think, quite some examples and also customer cases on how you can speed up data collection. That's the first pillar of becoming more productive to create efficiency. But of course, speeding up data collection is also very tightly coupling to assuring the quality and the exactness of your data, because what you capture in your actual test with your test object becomes crucial to whatever you will be able to discover as insights later on. Secondly, I think we also illustrated that with TestLab you have a wealth of capabilities to not only capture data in an efficient way, but also to explore, let's say, and to create insights from how your design is behaving, how and to what extent you are meeting your targets, and what is the root cause when you're not meeting your targets. So you can also basically formulate from your insights clear recommendations on how to optimize and change the designs to actually create a better product. And last but not least, I think the link and the integration, the interaction between test and simulation becomes ever more crucial in doing so. I mean, insights come more from simulation in the early stages, of course, but test plays a key role in terms of providing the loads to simulations, in terms of updating and basically making the reliability of simulation models better. But also, I mean, evolving towards a real combined, almost like fused way, combined use of test and simulation, where you can, in your testing, during your bench testing or your field testing, use your simulation model to actually real-time feed the simulation model to create more insights, to apply maybe the principle of virtual sensors, And that is kind of an evolution to the futures that we think will make a real difference in terms of supporting productivity innovation and doing that still with very much efficient ways of test-based engineering and giving also new levels of productivity. So with that, I want to thank you for watching this presentation. I hope you've taken a lot of inspiration and ideas from the different capabilities and methods that we've presented, and basically that you will bring those into your daily test work.